let's solve this, this trigonometric equation. So what we're asked for is to find all values of theta that are between 0 and 2 pi that will make this equation true. So in this case, so theta is just a variable, generally reflects an angle. So we want to find out what values make this true. Well, the first thing I need to do is I need to figure out a way to get theta all by itself to be able to solve it, just like when we're solving equations with polynomials or rational expressions, we try and get x all by itself. We need to get theta all by itself. So the first thing I'm going to do is I'm going to subtract 1 from both sides. So now I have radical 3 tangent 3 theta is equal to negative 1. And again, I'm trying to get theta all by itself. So I'm going to start by getting tangent 3 theta all by itself, and I'm going to divide both sides by radical 3. So divide by radical 3, and I have tangent 3 theta is equal to negative 1 over radical 3. Well, this is kind of a tough problem to answer because I could probably figure out where tangent theta is equal to negative 1 over radical 3. But this 3 right here, this omega, is changing the period of my parent function of tangent theta. It's making it probably happen a lot more frequently than just the regular parent function of tangent. So it's likely that I'll have more answers than I would if I was just going around the unit circle one time. So in order to make it easy to solve, what I'm going to do is I'm going to go over to the side, I'm going to say, well, 3 theta is awkward, so I'm going to set it equal to x. I'm just changing the variables. So now I have tangent x is equal to negative 1 over radical 3. And because of my familiarity with the unit circle and my familiarity with trigonometry in general, and what you could do just by looking at the unit circle, is you would find out that x is equal to 5 pi over 6 and 11 pi over 6. That's if I go around the unit circle one time. Those are the 2 spots that this is going to be true. And I'm pretty comfortable with that because I know that tangent is negative in these 2 quadrants. So I'm going to write that a little bit differently though, because right now I need to identify every single possible answer. So what I'm going to write is I'm going to write x is equal to 5 pi over 6 plus pi k. The pi k represents the period of the tangent function, pi, and the k is an integer. I'll write that over here. K equals any integer. Because I can go, if I find one answer right here, I can go around the circle pi, and I know it's going to be the same answer. I can go around another pi, and I know it's going to be the same answer. I can go around another pi, I know it's going to be the same answer. I could have started there and gone backwards pi. So as long as I multiply pi by any integer, I'm going to get in a spot where the tangent is going to equal negative 1 over radical 3. So I'm writing it like that. And then I'm going to write the other answer as well in the same way. I'm going to write x is equal to 11 pi over 6 plus pi k. And just again to emphasize this, this pi k right here, I use pi because it is the period of the tangent function. If I was doing a similar problem with sine or cosine, it would be 2 pi k. Because 2 pi is the period of the sine or the cosine function. Well, this is all well and good, except that if I go back to my original problem, I see it's asking me to solve for theta. And when I go to these two equations that I have, I don't see a theta anywhere. So I have to introduce theta back into the equation, and I do that easily because I have set 3 theta equal to x to make this problem simpler to solve. So I can just come back to my two equations, and I can erase x, and I can say, well, that's the same thing as 3 theta. I can erase x here, and I can say that's the same thing as 3 theta. Well, I'm trying to solve for theta all by itself, but I can do the algebra here. I'm going to multiply 3 theta by 1/3 to make that 3 go away. And if I do it on the left side, I have to multiply the right side by 1/3. So now I have those 3's are going to cross off. I have theta is equal to, and let's distribute this over here, it's just equal to 5 pi over 18 plus, distributed to there, pi over 3k. And similarly with this one, I'll multiply by 1/3, and I get theta on this side, and I multiply by 1/3 on this side, and I get 11 pi over 18 plus pi over 3k. Those are going to be the two equations that I use to find all of the possible solutions for this equation right here. And then we're going to figure out how to make sure that they're all between 0 and 2 pi. So let's come back down to our equations. And I'm going to do one more thing to make my life a little bit easier. This is 5 pi over 18, and this is pi over 3. And I know that as I'm doing this work and I make my table, I'm going to have to figure out a way to add those two together. And if I'm adding fractions, it's a whole lot easier to add them together if I have a common denominator. So instead of pi over 3, I'm going to change that. I'm going to multiply that by 6 over 6. And I'm going to get 5 pi over 18 plus 6 pi over 18k. And over here, I'm going to get 11 pi over 18 plus 6 pi over 18k. That's going to make my life a lot easier. And the other thing I'm going to do to make my life a lot easier is I'm going to say, well, I know I was looking for my answer between 0 and 2 pi. Well, since I'm dealing with 18ths, I'm going to say I would like it between 0 and 36 pi over 18. So now everything has the same denominator, and I can go about setting up my table. Well, I think the first thing I'll do with my table is I'll put in my k's. So I'm going to have k, and I like to start with like -2, and then -1, and then 0, and 1, and 2. Those are the k's that I'm going to try. And I kind of need to move this over a little bit because I have to get some room for my equations. So my two equations are theta is equal to 5 pi over 18 plus 6 pi over 18k. And the other one is 11 pi over 18 plus 6 pi over 18k. Let's just double check, make sure those are right. Yep, those look right. Okay. Now I'm going to start testing k's. In other words, I want to find out what my answer is going to be with different values of k. So I'm going to start with -2, and since my k is right here, -2 times 6 pi is -12 pi, and -12 pi pi plus 5 pi gives me negative 7 pi, and it's all over 18. See, the nice thing about making the common denominator makes it a lot easier to do this problem. Negative 1 times 6 pi would be negative 6, plus 5 pi would be negative pi over 18. 0 is easy because anything times 0 is 0. So this just becomes 5 pi over 18. Positive 1 gets me 6 pi plus 5 pi gets me 11 pi over 18. And positive 2 times 6 gives me positive 12 plus 5 is 17 pi over 18. And now I'm going to do it with my 11 pi over 18 plus 6 pi over 18k. So again, negative 2 times 6 pi is negative 12 pi plus 11 pi. That would give me negative pi over 18, negative 1 pi over 18. I do the 1. Negative 1 times 6 pi is negative 6. Plus 11, that gives me 5 pi over 18. I do it with 0, that's easy. I get 11 pi over 18. I do it with 1, and I get 6 plus 11 is 17 pi over 18. And I do it with 2, that's 12 plus 11, that would be 23 pi over 18. So I've got a whole bunch of numbers written down here, but I know that they have to all be between 0 and 36 pi over 18. So that eliminates, let's use a different color here. That eliminates all of these negative ones. 5 pi over 18 is between 0 and 36. 11 pi over 18 is between 0 and 36 pi over 18. 17 pi is between 36. So these three are good. And you'll notice they're just repeated right down here. And 23 pi over 18 is also good. Well, this is kind of nice. I have found that all of these are answers that will make my original equation true. Well, the question is, though, am I finished? Now, I know that if I go over here and I had k as negative 3 or k was at negative 4, it really wouldn't make any difference, because if I multiplied negative 2 times 6 pi and I got negative numbers, certainly if I multiply negative 3 and negative 4 times 6 pi over 18, I'm going to get even worse negative numbers. So those aren't going to work at all. But the question is, what if k, my 17 pi over 18 is good, my 23 pi over 18 is good. I don't know what's over on this side of the table. I have to find out. Until I start getting things that I can cross out, I have to keep going. So let's try 3. So if I have a 3k, that would be 3 times 6 is 18, plus 5 is 23 pi over k. 23 pi over 18. And then 3 times 6 is 18. 18 plus 11 is 29 pi over k. 29 pi over 18, I'm sorry. Well, I have to go a little bit more. I have to try 4. Well, 4 times 6 is 24, plus 5 is 29 pi over 18. And 4 times 6 is 24, plus 11. 24 plus, I got to do that, plus 11. That's 35. So this is 35 pi over 18. Well, it looks to me like I have to go even a little bit further, and I'm running out of room. How am I going to do this? I think I'll do it down here. Let's see what I can do. Let's try k is equal to 5. Well, if k is equal to 5, 5 times 6 is 30 plus 5 is 35 pi over 18. So that one works okay, which I already had that one right over here, I notice. And 5 times 6 is 30 plus 11. That would be 41 pi over 18. And that one is not going to work. That is outside of our range. So this 35 pi over 18, I already had that over here. So I'm just going to expand my correct answers to include all of those. And those are all of the correct answers that I can find within the restriction I was giving, 0 to 2 pi. But that's a lot of answers. I think what I would like to do is check a couple of these answers, at least a couple of them, to make sure that they're okay. And first thing I notice is that I have this interesting relationship where diagonally the numbers are the same. I don't really need to repeat them twice. And the reason that they're the same is because I'm looking for answers of tangent that are between 0 and 2 pi once around the unit circle. And every pi on the parent, it just repeats itself. So I'm gonna, when I was adding pi k, they're just going to repeat themselves, and when I do tangent, I will always have this kind of a relationship where they repeat themselves for both formulas. So really, I'm looking at these right here as my answers. That includes all of them, and I would like to test some of them. So what I'm going to do is I'm going to come over to my calculator, and in the y equals, I'm going to enter my equation right here. So y equals, I'm going to go radical 3 tangent 3x, and the calculator uses x as the variable. I close my parentheses, plus 1. So that's what my y equals, and I want to find out if it's going to equal 0. So I have it in there, my y1. So I'm going to go second, quit. I'm going to go back to my main page, and I'm going to say, I would like to evaluate that function for some of these angles right here. So let's do it like this. I'm going to go alpha F4, and it gives me a list of all of the y values, all of the y functions I've entered. Well, I've only entered the one in y1. So I'm going to say, I want to use that function, y1. And I'll put a parentheses, and I want to evaluate that function for the number, the angle 5 pi over 18. So I'll go 5 second pi divided by 18. Close my parentheses, hit enter, and I get the answer 0, which is exactly what I was hoping to get. That's the answer to the equation, is 0. Well, let's just try another one just to make sure we're doing okay. Well, let's go alpha F4, and I want my y1 function, and I want to evaluate that function for, let's say, 23 pi over 18. So I'll go 23 pi divided by 18, close my parentheses, hit enter, and I get 0. So I'm really feeling pretty comfortable here, in addition to the fact that I know that my formula was adding 6 pi over 18 to each one, and I can see, well, 5 plus 6 is 11, 11 plus 6 is 17, 17 plus 6 is 23, 23 plus 6 is 29, 29 plus 6 is 35. So overall, I'm really pretty comfortable that I have given all of the answers possible to this equation.